We all want our stuff to be faster, right? Smaller, more powerful. But for years, there's been this hidden problem that's been holding everything back. So in this explainer, we're going to dive into how this unbelievably tiny technology is about to solve one of the biggest challenges in electronics.
I mean, think about it. You get the latest phone, the newest laptop, and yeah, sure, it's better. But is it that huge leap forward we used to get every single year? It kind of feels like things have slowed down, doesn't it? Well, you're not just imagining it. There is a very, very real reason for this.
And here it is, the culprit. The reason for this slowdown? It's the memory in your device. Yeah, that component that has to store and retrieve all your data, it's just struggling to keep up with everything else.
All right, so let's dig into this. What exactly is this memory bottleneck? And why is it suddenly such a massive deal for the future of, well, all of our electronics?
Okay, so here's where you can really see the problem. For decades, processors, the brains of our devices, they've been getting faster and faster at this just incredible rate. But the memory, the traditional memory technology, it just hasn't kept up. It's like having a supercar engine stuck in city traffic. That super fast processor is just sitting there waiting for the slower memory to finally catch up. And this whole bottleneck thing, it's happening at literally the worst possible time. Because what do we all want from our devices? We want them faster, sure, but also more efficient, smaller, with batteries that last forever. We're demanding so much, and it's putting this insane pressure on a memory system that's, well, it's already stretched to its breaking point.
So, what if the answer isn't just trying to make the old tech a little bit better? What if it's about starting fresh with something completely new and unbelievably small? And that, right there, brings us to the nano-size solution.
Now, you've probably heard the word nanotechnology thrown around, but what does it actually mean? Well, here's the gist of it. It's engineering on the scale of atoms and molecules. I mean, we are talking about building things from the absolute ground up, atom by atom, to create materials and devices with totally new, super powerful properties. And this quote from Dr. Amar Nafe, who's a real expert in this stuff, just hits the nail on the head. The path forward isn't about throwing out everything we've already built. Nope. It's about bringing together the world of nanotech with our traditional electronics. He calls it a marriage, and that's exactly what's going to unlock that next big leap in performance. And look, this isn't just some theory or a concept for the future. It is happening right now. And a really big piece of this story is actually unfolding in the UAE, where researchers are making some huge strides in this exact field. So, right at the center of all this progress are two researchers, Dr. Amar Nafe and Dr. Nazik El-Attab. What they've done is compile years and years of their groundbreaking research into one single, really important book. You can think of it as the blueprint, the instruction manual for the next generation of computer memory. So, what's the big deal about their work? What does it actually give us? Well, their book doesn't just explain the how, like how this new nano memory works. It also lays out exactly what our future gadgets are going to need, and it details the new ingredients, these nanomaterials that we need to actually build them. It's the whole shebang, a complete guide for the people who are going to make this stuff a reality. And what's pretty amazing is where all this happened. This really cutting-edge research was done right in the UAE at Khalifa University. It was only possible because they have the country's only cleanroom facility, which is the super specialized, ultra-clean environment you absolutely need to work on things this small. It really shows a serious commitment to becoming a leader in nanotech. Okay, and this is a really important point. Nanotechnology isn't some sci-fi dream anymore. It's not something that's decades away. It has already made the leap from the lab and into our everyday lives. I mean, just look at how fast things have changed. A little while ago, nanotech was just a cool-sounding buzzword, right? Something out of a movie. But fast forward to just a few years ago and boom, it's already in mainstream applications. And today? Well, as we're seeing, it's become absolutely essential for pushing technology forward. And get this, you might actually own some nanotech right now and not even realize it. You know those newer TVs with the really, really vibrant colors? A lot of those use something called quantum dots. That's nanotechnology. It's even in some makeup. So the point is, this tech is already here. It's in the real world, and we know it works. All right. So if this stuff is already here, and it's so important, what do we need to do to build that nano-powered future that feels like it's just around the corner? Well, it's going to take more than just a few brilliant researchers in a lab. And Dr. Nafei points this out perfectly. The next critical step is education. We have to train the next generation of scientists and engineers. We need to give them the tools and the knowledge to work with these new nanomaterials, because they're the ones who are going to take these amazing breakthroughs and actually build the stuff we'll all be using in the next few years.
So let's just recap. We started with this fundamental problem, right? A bottleneck that's been holding our tech back. And we've ended up with a revolutionary solution, engineered at the atomic level. The research, it's done. The materials, they exist. The foundation for the next wave of technology is being laid as we speak. So the only real question left to ask is, now that we have the very building blocks of matter as our toolkit, what on earth are we going to build next?